Upgrade complete.
No one shall be the wiser. It has begun. No one shall
Job's
be the
done.
wiser.
Job's done. Job's done. Job's done. Job's done. Job's done. Job's done. Job's done.
I am prepared. Enlighten me.
I stand
Out with
ready.
it. I bid you, out with it. I bid you. I am prepared. I bid you. I am prepared. No one shall be the wiser.
Job's done.
I bid you,
Upgrade complete.
enlighten me. Out with it. I bid you. I am prepared. Thy bidding. For my brothers, I am prepared.
Upgrade complete.
Thy bidding.
Upgrade complete.
Enlighten me. Out with it. Enlighten me. Out with it.
Bravo, mesdemoiselles. Cette année dans la catégorie révélation soliste instrumentale. Piano. Bravo. Et merci.
Out. Enlighten me. I am prepared. Out with it. Enlighten me.
Research complete.
Thy bidding. That's a given. My brothers. It has begun.
Job's done. Job's done. Job's done. Job's done. Job's done.
That's a
Job's
given.
done. Job's done.
I am prepared. Has begun. No one shall be
Job's done.
lost.
Job's done. Job's done.
That's a given.
Job's done.
Out with it. Enlighten me. I am prepared. Enlighten me. I am prepared. Thy bidding. Out with it. Thy bidding. Out with it. Thy bidding.
Job done.
I hear the summons. I am prepared.
Upgrade complete.
I bid you.
Upgrade complete.
Enlightened. I bid you.
Yes.
谁人都可以，哪會怕有一天，只你知不知道？
That's a given.
你知
Not
不
saying my purpose.
知道？
Job's
Has
done.
been done.
Job's done. Job's done. Job's done. Job's done. Job's done.
Who you
Job's
want
done.
me to
原谅。
Upgrade.
Where she want me to go? Where she want me to do with it?
Upgrade complete. Upgrade complete. Complete.
旁人來回關心中安慰愛已沒結果，熱烈地開解一生，等你也是奈何，彷彿我在變錯。旁人靜靜看看我昨天哪裏出錯。 我是從逢迷失中飄離，情是歌，是舊若是怎執着的某個故事，可惜這份信念到今天多
Someone coughed it up.
情偏偏真真的你，愛假想某為別離舊。 孤孤單單的我，會否你就是這個？而飄飄忽忽的你，到真的決定別離後，留低空空虛虛的我，會否等你就似這個？你知不知道？你知不知道？
Out with it.
我等到花儿谢了，你知不知道？你知不知道？
I am prepared.
我等到花儿
Where she want
也
me to
谢
go? Where she want me to
了
go?。I bid you.
Upgrade
Where
complete.
she want me to go? Who you want me? I am prepared.
Upgrade complete.
What you want me to do? Out with it. I
Upgrade
bid you,
complete.
my brothers.
Job's done.
Out with it.
曾天天真真的你，
Job's done.
會假想某日便離舊。如孤孤單單的我，會否等你就似這個？而飄飄忽忽的你，都真的決定要離開。喜歡風的輕輕我，會否等你就似這個？你知不知道？你知不知道？我等到花也谢了。你知不知道？你知不知道？我等到花也谢了。等你等到我心痛，等你等到你给我所有感觉成空，却一切都随风。你知不知道？你知不知道？我等到花儿也谢了。你知不知道？你知不知道？我等到花儿
Upgrade
也谢了。
Upgrade complete. Upgrade
My
complete.
brothers. No
我
one shall
等
be wise.
到花儿也谢了。是你吗？高高我从藏千年啊，看尽了人世离与散，多少功名似尘埃。
是我傻，总是在寂寞夜里望，你是原是却是迷惘，仿佛告诉我生命本无常。
来饮一首老诗，喝一杯老酒，明月啊，
别笑我痴，别笑我狂。
窗前明月光，疑是地上霜。举头望明月，低头思故乡。
窗前明月光，
I bid you.
Job's done.
疑是地上霜。举头望明月，低头思故乡。
Out with it. bidding. Begun. That's a given.
Job's done.
Has begun. All my brothers.
Job's done.
That's a
Job's
given.
done. Job's done. Job's done. Job's done. Job's done.
My brothers.
Job's done. Job's
Has
done.
begun.
Job's done. Job's done.
Enlighten me.
Upgrade complete. Upgrade complete.
I bow
am
to
prepared.
your will.
Enlighten me.
Upgrade Upgrade complete. Upgrade.
I wish only to serve.
Upgrade complete. Ready to
Out
work.
with it. I am prepared. My bidding.
More gold is required. More gold is
Et merci.
research complete. Research complete.
My bidding. No one should be wise. That's a given.
Job's done. 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 What do you want? Yes.
Enlighten me.
Job's
I
done.
am prepared. Out with it.
Upgrade complete.
I am
Research
prepared.
complete.
This outfit is full of birds.
今天我寒夜里
Out with
看
it.
樹飄過，為着冷卻了的心窩飄遠方。風雨裏追趕，霧裏分不清影蹤，天空海闊
I am prepared. Enlighten me. It has begun.
仍然只有自我，永遠高着我歌。
Job's done.
This battle I am prepared. Out with it.
Job's done.
會怕有一天會跌倒，背棄了理想。
My bidding. My bidding. Outward. I am prepared.
Where you want me to go? Upgrade.
My bidding.
What you want me to do? Job done. Where you want me to go?
Out with it. It has begun. Enlightenment.
Job done. What you want? Upgrade
Out with it.
complete. Something need doing?
My bidding.
Upgrade complete.
I am prepared.
Upgrade complete.
My bidding. Out with it.
Ready to work. Ready to work.
不知道，你知不知道，我的是你。现在跟我对话，我所看见的，我以为放心去问问我已不过。你哋開解一生，等你發現愛過，這分我再變要起跑，唔錯。旁人來靜靜看看我昨天那裏出錯，我是從風迷失中飄起這首歌。是舊若是怎執着的某個故事，可惜這份信念到今天多麼無錯。曾天天真真的你，我假想某日要離去。如孤孤單單的我，會否等你就似這歌？飄飄忽忽的你，到真的決定要離去。眼空空虛虛的我，會否等你就似這歌？你知不知道？你知不知道？我等到花也谢了。你知不知道？你知不知道？我等到花儿也谢了。
My bidding. Out with it. My bidding.
What you want me to do? Upgrade complete.
曾天天真真的你，我假想某日便離舊。如孤孤單單的我，會否等你就似這歌？
Upgrade complete.
飄飄忽忽的你，到真的決定要
Job's done.
離舊。
My bidding.
留低空空虛虛的我，對否等你就似這歌？你知不知道？你知不知道？我等到花儿也谢了。你知不知道？你知不知道？我等到花儿也谢了。等到我心痛，等你等到没有梦，所有感觉已成空， 就让一切都随风。你知不知道？你知不知道？我等到花也谢了。你知不知道？你知不知道？我等到花
Something you're doing?
也谢
Something you're
了。
doing? What do you want?
Upgrade complete.
Build more
farm.
What do you want?
Build more farm.
Yes.
Upgrade complete. Upgrade complete.
Something you're doing?
Thy bidding.
Upgrade complete.
Enlighten me. Thy bidding. Out with it.
The dead shall serve.
Upgrade complete.
All my brothers.
Upgrade
That's a
complete.
gift.
Job's
My
done.
brothers.
Job's done.
That's
Job's
a
done.
gift.
Job's done. Job's done. Job's done. Job's
That's a
done.
gift.
Job's done. Job's done.
brothers.
Job's done. Job's done. Job's done. Job's done. Job's done. Job's done. Jobs done. Jobs done. Jobs
My
done.
brothers.
Jobs done.
Has
Jobs done.
begun.
Jobs done. Jobs done.
My
Done. Jobs
brothers.
done. Jobs
No
done.
one shall be the wiser.
Not some there.
Jobs
Has
done.
begun.
Not some.
That's a
Jobs
given.
done. Jobs done. Jobs done. Jobs done.
No
Jobs
one
done.
shall be the wiser.
Jobs done.
My
Jobs
brothers.
done. Jobs done.
Has
Jobs done.
begun.
Jobs done.
What do you want?
Out with it. That's a given.
Upgrade complete.
begun. That's a given. What's happening? For my brothers.
Your move.
Job's done. Upgrade complete.
Battle awaits.
Thy bidding.
Upgrade complete. Upgrade complete.
I am prepared.
Job's
begun.
done. Upgrade
That's a
complete.
given.
Job's done. Job's done.
I'm all stocked and ready to
Where you want me go?
Waiting on you.
I am prepared.
Upgrade complete.
No one shall be the wiser. That's a given. For my brothers.
Job's done. Job's done.
begun.
Job's done.
Enlighten me.
Job's done.
For my
Job's
brothers.
done.
Out with it. I am prepared.
Upgrade
Out with it.
complete.
care for a cocktail.
I am prepared. Thy bidding. Enlighten.
What?
Out with it. Thy bidding. I am prepared.
Yes?
Upgrade
What you
complete.
want?
Upgrade complete. Upgrade complete. Upgrade complete.
What you want? Yes,
Out
chieftain.
with it. I am prepared.
Say the word. Need something?
Out with it. Out with it. Enlighten me.
Say the word. Need something? Say the word. Yes, chieftain. Say the word. Yes, chieftain.
I am prepared.
Research
No
complete.
one shall be the wiser. Enlighten me. Outward. It has begun. No one shall be
Job's
the wiser.
done. Job's done.
It has
Job's done.
begun.
Job's done. Job's
No
done.
one shall be the wiser.
Job's done.
That's a
Job's
given.
done. Job's done.
For my brothers. No one shall be the wiser.
Job's done. Job's done.
Enlighten me.
Upgrade complete.
That's a given.
Job's done.
I'm all stocked and ready
My
to
bidding.
go.
I pledge my loyalty.
Out with it.
You'll love my
I am
recipe.
prepared. Enlighten me. For my brothers. No one shall be the wiser.
Job's
This
done.
better be
My
good.
bidding. For my brothers.
Upgrade
Has begun. No one shall be the wiser.
Job's done. Job's
That's a
done.
given.
Job's done. Job's done. Job's done. Job's done. Job's done. Upgrade complete.
Out with it.
Wanna blow something up?
I am prepared. Enlighten me. I bid you.
那我威胁要吃这个，加上吃这个嘛，啊，认输了。
全新保利净，99.9%有效去除细菌和病毒。保利净口腔护具清洁定，
确实没法下。哎，我这是什么？什么是 WOD 联盟？这是什么？为什么出现了这个？哎，这是什么东西？我是参加到了什么比赛吗 ？WOD 联盟是什么？没很明白。好，没关系，我们就复盘一下吧。苏格兰还是一个我挺喜欢的一个棋，白方进攻确实火爆。不过这个棋我们最后从一个攻王的棋最终转成一个局面棋，没有饭团啊，这一步棋好像不好哦，可能马1-2更好是吧？马1-2把这个马可以带往王1去进攻。或者带到这，再到这啊，确实。那我直接换的话，我这棋反而变黑优了。象抓，车在一退，接砍可是他接砍不好啊，后吃不好，兵吃反而最好，这什么意思？兵吃，是人都会选后吃吧？可能是因为后吃的话有这个进来的问题。那如果兵吃的话无论哪一个兵吃，那我后可以继续管住这些黑格，然后我可以继续把这些兵给挺进可能这个是就是应该用兵吃的一个主要的原因。确实我之后被那个黑格被管住挺不舒服的他这边要吃这个兵，我是无论如何不敢吃了。H4， 好，差一点，但是换完后之后，这个棋确实优势就比较大。转成了一个胜势，很接近胜势的残局，然后再加上利用对方马这个不恰当位置，我们最终是把这个马给捉死了。好，这边是逼招因为我要吃他的马，那他的马要活下来只能走这个，那我们再一吃，那这就我刚刚说的威胁吃马又威胁杀这个点，这个棋地方确实不行。好，那今天这盘棋给大家展示了一下，有时候有面临危险的时候或是进攻碰到瓶颈的时候，我们可以考虑兑换掉对方的后比如说这个局面为什么是对后呢？因为对后之后，首先是我们的攻王已经被这个后彻底给限制住了，他把我们攻王的这个推兵的手段全部给管住了所以呢，我们可以透过兑换这个皇后继续争取让自己的兵有推进的动力。再来是兑换后之后，我们的车在低线有很好的一个发挥所以这个棋我们在关键时刻去对后进残局，那就能下到一个很舒服的局面。好，那今天这盘棋给大家介绍到这边，希望大家都有一些收获。那么我们就下次再见了，大家拜拜。好，那抓的这个黑格象是一个消除保护，下一步吃掉这一只马。好，那这个应该是赢了，多子。所以有时候看到好棋不要急着走比如说我刚刚第一眼看到是象吃兵，然后后吃马，那这样的话只是得到一个兵，但我现在可以直接去赢一个子那这边直接得到一个子，因为我们刚还多吃了一只马，我们刚刚象是直接交换掉这一匹马，而不是交换掉这个兵 那现在这个局面基本上是胜势了。但是不能大意。好，我们现在准备推D5，去反击这个中心，然后准备把我们最后一个棋子做一个出动。啊，那为什么这个马一直还没出来？因为现在马唯一可以出的位置是 C6，但是我的马不太想要放在 C6这样的位置去挡住我这个非常强而有力的白鸽象。啊，那我们现在推D5，推D5，同时把这个中心兵，好，他这边走一个将军，好，我刚刚讲到哪？我说推D5是把这个中心兵给站起来，再来是把这个低兵做一个交换。你可以发现，如果这个低兵一旦交换掉的话，白鸽象非常畅通，这个在低线的车也会非常厉害。啊，那这个是推D5的一个思路。那现在他抓我们这个后，我们可以考虑几件事情，一个是这个将军，一个是退回来，好像这个将军厉害一些。好，我们就将一手吧。将一手，我感觉这边有一个战术，我的直觉告诉我，这边打开低线之后，这个象可能会有一点问题。确实好像有点问题。首先，我将军他必须要跑王，然后下一步我吃掉这个兵，他再吃掉我这个兵，我马在吃，他象在吃，然后我象在吃。好，看起来是得子了，好像没得子也得到一个兵。啊，应该是多兵，对，得一个兵。好，那他兵吃的话，我马吃；他象吃的话，我再象再吃。啊，他这边直接用象吃，那我马吃上去。好，那这边这个象也没了，直接吃掉。啊，那他刚刚的问题就是这个低线瞬间被打开。啊，那我这边有一个将军，这个棋基本上已经赢了，多了2只亲子，一个马一个象，是完全多出来的。啊，这边还可以再做一个将军，好像要杀王了，只能车挡。哎，他还有这个王，这个怎么杀呢？将军，啊，这边走个跷跷板先，好，先跷跷板吃掉这个 C 兵，啊，这个战术叫跷跷板，将军一个，再将军一个，然后接着再吃这一只，吃掉这只。然后再将军一个，拉回原位。这边随时好像没有东西可以闪了，那我们出个子吧。啊，出个子。如果他要抓我这个象的话，我可以简单，好像走错了，是不是？没事，我可以象可以拉开，但拉开我是不是车要没了？也不会。好，我这边直接交换掉好了，做一个闪击交换换子的动作。好，那我们这边直接交换掉一个车，然后下一步 F5 把这个象给保住，马准备跳上去，车准备跳上来。这个棋应该是已经赢棋了。好，我们不要给他这个D线有任何的机会。好，那他可能会转移到 C 线。我希望这个 C 线还是被他给占了。好，不要让他进来。不让他进来，嘿嘿嘿，堵起来，全部都堵住。好，那这边出个车。啊，不要让对手有反击入侵我们家里的机会。这边将军一个，抽兵，再将军一个。这边可以考虑有没有杀棋呢？简单一点，下一步将军把这个车给换掉。哎呦，一不注意，这个时间快没了。好，他投降了。好，那么我们继续下一盘棋。今天都黑色，不知道什么原因。好，没关系。好，我们这盘总算是白色，对上一个日本的748分的选手。那我们这边走一个后兵吧，很久没走这个后兵了。好，对方走1-6，这个棋可以走1-4转回法兰西，我们就下个法兰西吧，1-4。 那我自己拿黑棋的时候是蛮喜欢下法兰西的。那我白色有时候也挺喜欢走法兰西防御。好，那这个可以吗？这个想要这样偷我这个兵，怎么看都不行啊。我这边就简单出个子吧。我简单出一个子，下一步马 F3 把这个后给踹走，那我就有中心出子遥遥领先，肯定是不行的。那想要4不杀吗？不会吧？好，马 F6 踹走这个后，过早出后就是有这样的缺点啊，我们就出动亲子去进攻他的后，他现在要，哎呦，莫非我走错了什么？这个兵即将要吃下来。吃下来的话是一个捉双，然后他现在又咬着我这个兵，什么情况？如果我先吃，可能要弃掉这个兵，能不能弃掉这个兵，把这个后给抓死？怎么可能会被他这样随手一个后 H5，后 H4 给弄懵了？我想想啊，现在他2个威胁。他要吃我这一只兵，又要过来捉双我。我可以考虑推起来，但是车兵就会没有。车兵没有的话，首先我是有一个 RG1 这样的棋去抓后一个先手，他的后可能可以去 H3，然后我们再走一个车 G3 去反抓他的后。他的后可以去哪呢？他后还有这个 H5格可以去，能不能把他的后抓死啊？算了，这个好像不能想太久，只能凭感觉了。我的直觉告诉我，这个车兵是非得弃不可啊，因为首先我们不可能把这个支兵给他，那这边中心最好的处理应该就是封闭起来，把这个白鸽象堵在家里，然后弃掉这支兵，借由弃掉这个兵去寻求一个反击。只是具体反击的计划，我只看到这个车 G1，好，那这个肯定是要走车 G1 了，必须要抓这个后，然后他后会唯一的格子是这里，也许我跳个马抓不抓得死？不行，跳马的话这支兵就没了，怎么抓死这个后呀？如果过来的话，还有这个这边再抓一手，他可以后 H5，但是抓不死呀。我们这个车再上去，他后又下来，能不能抓死他呢？抓抓看吧。必须这么抓，反正就算弃掉这个少了一支兵，但是至少我们出子很快，未来可能可以常换位。我们先确保不能让这个后随便逃回家，再抓一手。下一步象守住这个兵，也许。守住这个 H2兵，然后这个马可以挪动之后，也许可以去把这个后做一个抓死。当然这边我们是可以喝气，但是不可能愿意，对吧？好，我们走一个象 F4。 如果我们象 F4的话，象 D7象E7抓车，然后我们没有他象E7抓。这的话，我们可以吃掉这个兵。我们尝试把这个后给抓死吧。哇，我刚刚在干嘛？是不是这一步一走，那后几乎没了？那我刚没走。当然，他还有这一个，可是这边我们不会闪击。哦，好像不能闪。好，没关系。现在考不考虑走一个这个抓后？有点乱啊，这种复杂的计算还是比较烦。马 G1抓后，后只能去 H6，后去 H6之后，哇，乱，好烦。马 G1抓后，后去 H6。车 G4抓后，不行，抓不死。那象 F1抓后，象 F1抓后，后 H6，然后接着车 G4。闪击打后，然后他兵居看起来比较有戏。不对，不行啊，再想下去时间要没了，好吧，我们就直接走了吧。这样，先抓一个。象抓好奇怪啊！抓一个，就用象抓，不管了。可能时间要加速一点，再下去要调中啊。他选择给我后，这个是什么？一车一象换一个后。他直接认输，就这样。我还有点担心呢，不知道这个到底是什么情形。用电脑看一下好了。有点复杂，不过我感觉应该是我好。好，看一下这个棋都没有走错。他说1-5不对，他说应该走兵吃，那兵吃，然后呢？兵吃，然后短一位。那兵吃，那如果他不急着吃，那先吃我这个兵呢？那我再走车车，那他一样后 H3，那我们车车3，那一样后 H5。好，然后我们再吃一支兵，然后我们就不少兵，然后同时准备，比如说他象吃。 车 G5，后 H3，象 F1，是不是可以抓死啊？可以抓死这个象，那有点难算。好，可是我觉得我实战走应该问题也不大。看一下实战走，15。啊，白方还是优势，只是优势没那么明显。好，但是依然是优势。好，那他走这个 F6之后，基本上，好，那他送后基本上是一个很严重的错误。对，他应该要把这个后给退回去。那这个棋确实还可以下。那我当时是计算走这个车 G4。那双方还有得下。啊，白方稍好一点。啊，接着准备马 C3，后 D2。长换位，王跑掉，然后从这个王翼去做一个进攻。好，那我们继续，应该会是最后一盘棋，因为我们差6分就可以到800。这盘比较惊险一些。好，我们最后一盘，他走 D3，他不占中线，那么我们就占了。他不占中线，我们占中线。他走一个马 C3，依然不占中线，那我们占中线。嘿嘿，别人不占中心，那么我们就占中心。这个棋，好，我们就推吧。但推的话，中心完全封锁，可以。那这个白格象很差，那我们就是黑格象比较差一些。这个马这边看起来很厉害，但实际上踹一脚就得走了，一脚就，哎，这马是不是没了啊？这个马刚刚是没位置走了吗？哇，这个马跳进来死掉了。那我们这边多子直接换子，赢棋了。他刚刚这个棋显然是下不对，就是我这边踢这个马，他马应该要回到1、2这样的一个位置，他走到这个 D5 去，导致他的马没有位置可以走了。你看这边都被兵给封死了，这边被象给堵死了，这边啊，全部都是我的家啊，所以他马没有位置可以走。所以 C6一走，直接这个马被抓死了。好，那这个马直接没了。那这边简单换子，这个棋是一个胜势。他未来想要长一位，但是我们接着沿着后翼去打他，这个棋应该很轻松。好，马 F6 简单出一个子，抓一下这个兵。那么我们后E7去守住一下这个兵，未来可能象G4给予牵制，就是在这个，哎。又想干嘛？踹一脚，你又得走了。不太明白这个马 G5的目的。过来给我踹一脚，好，回家。啊，继续抓这个兵。那么我们短一位，接着准备 C5、B5 后翼进攻。先看一下他王怎么放。如果他短一位的话，我们简单交换棋子，简单进残局，迈向胜利。啊，你看他把唯一的好的黑格主教给交换掉，他剩下的主教是这个白格烂象。这个说实在，白方非常吃亏。然后我们又有中心，我们中心的兵全部放在黑格，那黑格象是比较差的，然而我们的黑格象顺利的交换掉，剩下的这个白格象就是比较好的那个象。那未来也许这个象去到 G4，然后马去到 D7，啊，子力配置就一切完美了。这个棋基本上是赢了。好，他把后拉出来做一个进攻，我们简单守住，出车去防守一下。啊，因为不想要走马 D7去防守，因为走马 D7去防守的话，这个象被堵在家里出不来了。这个马 D7什么时候走？要这个象先出去之后再走马 D7。下一步象G4，没有意外的话。
也倦了。
哎，送马了，后直接吃后拉马吃，我车吃得子。接着可能，这个怎么说呢？交换吧，但他可能。就交换，把这个象拉到这个位置。 多子就换着是吧？不需要做太复杂的事情。啊，他果然做这个，可能再踢一手，让我把这个象拉进去。他这象完全堵在家里了，非常差。好，抓我车，退，对，退就好了。下一步交换这个象。他现在唯一的优势是中间这2只兵，送象直接吃掉。啊，这个送子是绝对不能犯的一个错误，送子基本上送完就输了。好，我们把象拉走。如果他推兵的话，我们马可以钻到 D5 去，顺势钻往E3。啊，果然推了。那我们钻往这个E3这个好格子，这是一只铁马，没有任何兵可以踢走这一只马。这样的马一般是非常强大。那这一个马强大的本质在于这一只还有一只兵去支撑它。好，那这个兵我们一般称这个兵叫一个前哨据点。好，他这边踢我的一个象，我把这个象拉回来。其实拉回来有点猥琐，应该放在这个象 F5，然后再象 H7好一些，走的有点随手，不过没有关系。好，主要是优势太过于巨大。好，我马随时可以跳进去，但我这边不着急。认错吧，我刚刚走错了，我觉得刚刚不应该回来。好，那我现在拉回来吧。有时候下错就认错一下，当然最好是不要下错。那主要是这边优势太过巨大，所以刚刚走的有点随手。那未来可以马跳进去，但我想要先把我最后一个棋子给带出来。送车了，这个棋赢了。真要跳进去了。现在多了太多子了，真的是多太多了。我考虑还一只马给他，因为他中心的兵群有点烦。好，就还一只马，还掉一只马，但是我可以想都不用想，就可以顺利把他中心的这几只兵全部吃光，还是挺划算的。这只兵也要没了。下一步车可以带出来，它唯一的优势就是这个中心，那我一只马可以摧毁它唯一的优势，那这个还是划算的。好，他想要
111 power 3 plus 666 power 3 plus 888 power 3 equals to x power 3, and now we are going to find the value of x. And just keep in your mind that we are not supposed to be using calculators of any kind. Please don't forget to give thumbs up to this video. So let's go ahead and get started with the solution, and here's the very first thing we are going to do. Let's focus on the left hand side of this equation, this part only. And here I have copied down, and let's go ahead and manipulate these terms. 111 power 3, I'm gonna just leave it as it is, plus 666 could be written as simply 111 times 6 and then power 3, and plus likewise 888 could be written as 111 times 8 and then power 3. And here's our next step. Let's focus on these terms, 111 times 6 power 3. And here I have copied down 111 times 6 power 3. This could be written as 111 power 3 times 6 power 3. And likewise, let's focus on this part, 111 times 8 power 3. And here I have copied down 111 times 8 power 3. This could be written as 111 power 3 times 8 power 3. So therefore we can write this one as 111 power 3 plus 111 times 6 power 3 could be written as 111 power 3 times 6 power 3 plus this one could be written as 111 power 3 times 8 power 3. And now we can see that 111 power 3 is in common among all these three terms, so we can factor it out. So let's go ahead and factor out 111 power 3 outside. So we are left with 1 plus this 6 power 3 and then plus this 8 power 3. Now let's go ahead and further simplify this one. 111 power 3, and here inside this parentheses 1 plus 6 power 3 is same as 216 plus 8 power 3 is same as 512. So this could be written as 111 power 3 times, if we add all these numbers, that is going to give us 729. And now we know that 729 could be written as 9 power 3. So let's go ahead and write it down. So 111 power 3 times 729 could be written as 9 power 3. And now this in turn could be written as 111 times 9 and then whole power 3. And now 111 times 9 is same as 999 and then power 3. So thus we can see that our this left hand side 111 power 3 plus 666 power 3 plus 888 power 3 turns out to be equal to 999 power 3. And if we now compare this equation with this our original equation, then we can see that this x is going to be this part, which is 999. So this is our x value. So thus our x value turns out to be 999. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.
You joined me today in ancient Greece. It's
wow, this doesn't look.
You joined me today in ancient Greece. It's
wow, this doesn't look like. Thank good lighting.
Thanks. It's not what you're expecting, but it's 6th century BC, and in particular we're on a Greek island just off the coast of Turkey. It's called Samos, and I know what you're thinking. You'd like to dig a tunnel through a mountain, wouldn't you? The question is, how on earth do you dig a tunnel through a mountain when you don't have access to any modern equipment? I'll tell you how you dig a tunnel through a mountain. Okay, so here is your mountain. Lovely. Now, there are a couple of things that you need to dig a tunnel through a mountain. You're going to need to have an entrance and an exit. Those are the two requisite components of a tunnel. So let's say you want to go in here and you want to come out here. Now, the thing is that you can't just start digging in here and just hope that you'll come out here. It's not going to work, right? You need to make sure that you hit the right bit. So what people tend to do, this is what they do for the Channel Tunnel, for example, is you start digging here and you start digging here and you just hope that they line up. Except that, I mean, you're unlikely to find each other in the middle of a mountain. So you need a technique to make sure that these two lines end up meeting up in the middle. And the way that you do that is by using triangles.
I would have thought if you made absolutely sure you were digging in a straight line, you'd be alright. As long as you can always, as long as you look behind you and the whole is still behind you.
Yeah, but the straight line. Hang on, if you were in a straight line, okay, so let's imagine that you. Let me do like a contour of this mountain. It's quite a wobbly mountain, this one. So you want to go in here and you want to come out here. The problem is that if you dig in a straight line, you could end up over here.
Right, so how do you make sure
How do you make sure that you get exactly there? And it's not like you can just stand on the top of the mountain and you go, oh, heading that way, lads. You know what I mean? Because you can't, when you're standing over here, you can't see around there.
Right.
So it's really hard to even know.
I feel like in the era of GPS, you could just do the straight line.
In GPS, I think you probably can.
Right.
I think you probably can. Apart from the fact that you're in a tunnel, I don't think signal's great in tunnels, but...
But if you start in a straight line and then just keep looking behind you to make sure that the hole's still there, you know you're going in a straight line. Anyway, so you're saying the main problem is you can't see the other side?
You can't see where you're going, yeah, exactly. So the way that you do this, it's very neat. So you try and walk around from one side of the mountain to the other, and as you go, you want to try and stay at the same level as you go around. Every time you take a step south, you add it up. Every time you take a step to the west, you add it up. And you're very careful about how big all of your steps are as you're going. Maybe you do this twice, just to make sure you've got the right numbers. You've done it all in units and right angles, and you've been really careful all the way along. Because even in ancient Greece, you can imagine it'd be quite easy to construct a right angle, wouldn't be too difficult. But in total then, imagine that you have taken 84 steps west and you have taken 13 steps south. So effectively then, to get the direction from one place to the other, you are talking about a triangle with those as the sides. So you know it's going to be 84 along there and 13 along there. And you know that that's a right angle because you've only ever walked south and west. And so you have this very nice, neat triangle. I deliberately chose one that was a Pythagorean triple. You're welcome. So this is 85. So now, actually, when you are at the entrance to each of these tunnels, you can construct a much smaller version of the same triangle and build it here. And if you make a kind of really long rod to sort of extend that angle, and you do the same thing over here, so you've got another version of the triangle here, then you should have these two lines, these two angles that will meet really perfectly in the middle. So the only thing that you've got to be careful of now is when you're digging, to make sure that you stay perfectly flat. You don't want to go up, you don't want to go down. And the way that they do that is that they put water in the tunnel. And then as they're digging, they make sure that the water just sits nice and still, rather than dripping in one direction or the other.
Like a spirit level?
Like a spirit level, exactly. This particular mountain, this is Samos, and this was in 525 BC. Polycrates, I don't think it's called Polycrates. How do you pronounce?
我等到花儿也谢了。
Our forces are under attack.
I am prepared.
Upgrade complete.
For my brothers. That's a given. No one shall
Job's
be wise.
done. Job's done.
For my brothers.
Job's done. Job's done. Job's
No one
done.
shall be
Job's
wise.
done. Job's done.
是我傻，总是在寂寞夜里望，你是越是
Someone's opening it up.
That's a give up.
Job's done. Job's done.
I bid you.
Upgrade complete.
Out with it. I bid you. I am prepared. Out with it. My bidding. No one shall be the wiser. It has begun.
Job done. Upgrade complete.
That's a given. For my brothers.
Job's done. Job's done.
Out with it.
Upgrade complete.
I am prepared. No one shall be the wiser.
Job's done.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru, au piano. Bravo. Et merci.
By bidding, I am prepared.
How may I serve? Upgrade complete. Upgrade complete.
也會怕有一天會跌倒。
That's a given. It has begun.
背棄了理想，
Job's done.
誰人都可以。
Enlighten me.
也會怕有一
For my
天
brothers.
只你共我。
Job's done.
By bidding.
今天我寒夜裏看雪飄過，為着冷卻了的心窩飄過。夢裏分不清影像。 Job's
Job's done. 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 Job's done.
Out with it.
Complete. Complete.
My brothers.
Job's done.
背棄了理想，誰人都可以。哪會怕有一天只你過？
Thy bidding.
Oh, it's Polycrates. Whatever. Polycrates, he wanted a tunnel. you can shoot. Polycrates, he wanted this tunnel. It's a kilometre long. 525 BC this was built, and this is exactly the technique that archaeologists think that they used. And when they did so, they did incredibly well. There was a tiny bit of zigzagging at one end, and they think it was because they were trying to work their way around some quite difficult rock, but then they re-established this sort of plumb line, as it were. And when these two tunnels met in the middle, there's like a tiny little step of 60 centimetres. It's like this unbelievably remarkable achievement with just some triangles.
How do you know where to put those triangles so the triangles are at the right?
That's got to be a line that runs exactly east to west, and that's got to be a line that runs exactly north to south. Do they have compasses?
Yeah.
I'm assuming they had compasses.
Well, they knew. They had the sun.
They had the sun. Yeah, that's true. You're open and closed to the tunnel. They actually need to be at the same level before you start. You know, the water.
Like the same altitude.
Yeah, the same altitude, exactly. Your water thing wouldn't work if you had one of your. If you were like, yeah, let's start there, and you hadn't worked out that actually one was much more uphill than the other. Now, this is something they're not quite sure about how they did it, how they managed it, but there is some suggestion. I'm not convinced by this, but there's some suggestion. Some archaeologists think that created this tower and then got a massive long stick. I mean, maybe I haven't understood this quite right, but my understanding of it is they went up to the top of a tower and then they dangled a big long stick down, and then they sort of swung it around the mountain. So they were like, oh, there you go, that's a nice point right there.
You could use a rope for that, surely.
And make it straight, yeah.
Like taut, although it's pretty hard to keep a rope that long taut.
Yeah, it's like a kilometre. But I don't think they built a kilometre long stick either.
No.
Anyway, some mysteries remain unsolved, shall we say.
This episode was supported by Brilliant.
loving creators of puzzles and courses like these. Brilliant's loving creators of puzzles and courses like these. Brilliant's all about interaction, getting you to move things around, click and think, slide things into place. That's the key to understanding, really engaging with what you're learning. Check out their huge and ever-growing library of material at brilliant.org/numberphile. Using that /numberphile will bag you a 20% discount on their premium subscription, by the way. And if you're looking for that something special for the learner in your life, you can also give a Brilliant subscription as a gift. Check them out, brilliant.org/numberphile.
Set of lizards that use, the way that the males dominate one another follows a rock, paper, scissors type game. There's the orange lizards. These are the guys, they're called ultra dominant, right? They've got big territories, they've got loads of females. They're the big guys, right?
我等到花儿也谢了，旁人來靜靜看我到底愛上等什麼，旁人來會關心中安慰愛已沒結果，熱烈地開解一生，等你也是奈何。彷彿我在拼命要起可援助，旁人來靜靜探聽我昨天哪裏出錯，何時從逢迷失中飄起這首歌，是舊日時認真執着的某個故事。可惜這份信念到今天多麼無助，曾天天真真的你，愛假想某日便離舊。如孤孤單單的我，會否等你就似這歌？而飄飄忽忽的你，到真的決定便離舊。留低空空虛虛的我，會否等你就似這歌？你知不知道？你知不知道？我等到花兒也謝了，你知不知道？你知不知道？我等到花兒也謝了。曾天天真真的你，愛假想某日便離舊。如孤孤單單的我，會否等你就似這歌？而飄飄忽忽的你，到真的決定便離舊，留低空。
去撼动我这只兵，然後去吃掉我人马，但是我可以簡單狙吃兵，然後守住這只馬。如果他兵吃了，我下一步先走這個狙18，把這個馬給保住，下一步再狙吃兵。那他王是被將軍的，所以他沒有時間去吃我的馬。那這個兵是一個死兵，所以我們不着急吃。就，現在不能去吃這個兵了。 好，我们拉一下吧。这个狙放在这个王的嘴里怪恐怖的。他直接去拿狙去交换我们的马，他没武器了呀。这其实他可以投了。好，我们这边走一个 B6， 不让他的王可以有挪动的机会。吃一下这个兵，准备过来进行一个杀王。好，准备杀王。如果他唯一的解法可能是走这支兵或这支兵，让王有一个逃跑空间，他选择走了这一支。可是我是不是可以连江杀？感觉有一个连江杀。对，是一个杀棋。然后再摆过来杀王。好，那我们今天顺利的爬到了这个800分。好，那希望大家透过今天的对局教学都能有一些收获。那么我们下次再见。他就直接占领这个一线，还有会这个一线是那个次一线。那如果我退回来，那他直接吃我的局下一线，他一样可以走这个出一半，对区域没有什么太大。
星际冒险起航，喷射压制整轮百搭，战舰追击随机百搭，全面轰炸爆出宇宙大奖，星城 Online。
直接交换掉，然后准备买一溜把自己这样子。哦，现在突然看到他有一步棋，是这个打过来。我这个第6兵是不是守不住啊？马1 4，我这个兵清晰吧？好，我这个第6兵。多一支兵，但是对方有优势就是多一支兵，那我选择把我这个兵给强行留下来。好，来抓了。那我这边的话，调整一下我另外一个小的位置，直接反抓这个。哦，糟糕，我看到一步棋，它可以吃的，它直接吃的话，我是不能吃。刚如果他直接吃我这个兵，我是不是不能吃的？因为如果是没吃，他有个底线杀。好，那我先处理一下底线的问题。准备去，下一步准备马C7去抓这个兵。我这个兵直接给他算了。意思是说打不打这个下面交换。下一步过来是一个好，我直接换掉，然后接着马47。好，反转，这边就没了。这盘棋就感觉 下不是说太熟，再看一下是哪边，再一下。而且花了第一名啊，如果是那个名字的时候，里面会形成一个比较复杂的对应局面。也希望把这个名给它吃。有没有办法呢？没有，好像。好，我们吃吧。但这个，哎呦，完了，走歪了，我操！我要吃，我刚刚在想，结果按到 A6，啊，这个棋凶多吉少啊！这马跳到边边去很差。哇，这个马，这怎么办？这个兵一定要守，但一守的话，他马 C6一走，我不就完了？输了感觉。好，不行，这棋得果断一点。啊，只能走。啊，这1分28秒，我可能没有办法解释太多了。我现在赶紧把马复活，这边准备跪了，想办法去争取和棋。哇，这个马 A6太伤了，至少要吃个兵吧。啊，原本是想要放回原位的，不知道为什么没放好，直接这个直接走到马 A6去了。吃掉兵吃，哇，异常危险，只能吃了，没得选。然后狙过来，然后王上，这个兵争取推下去，这棋基本上要输了。如果我刚不走王上来的话，他这个车是直接下来。好，这个死命推这个兵，这棋其实没救了。啊，王跟过去看看。哎，这个兵给我吃，什么意思呢？哎，有点希望。哈哈。冲啊！好，一人一只。再冲我这边。交换吧。好，一人一只。这只给你，我吃你这只，形成3对2。这个棋至少不输。打一个将先。哇，打将这个兵丢了，我吐了。运气不错，他的车没办法留在这个线路上。好，形成了车3兵对2兵的一个棋，可以抢救，只是要走快一点。打个将，因为有点水手，算了算了。他就把这个兵冲高，这个兵被压住了，王准备躲进去。目标推这个兵，王下来。其实是个和棋。不会就这样和了吧？挑逗一下他，反正这个棋不可能输。多一只兵怎么说也得戳一下他，看一下他会不会犯错。这个棋只要进车兵场就比较有赢的机会，没进去就很难。 很想冲这个兵，冲一下。把车挂在这边。这时候有 pre-move 就还不错啊，冲这个兵吧。计划。哎，通路兵有机会。我现在有一支通路兵。有通路兵就不一样，啊，这边小心不要走错，真可怕！哇，啊，才滑在这里，剩30秒，骗一个，然后再拉出来，推个兵，上个王。哦，走错了，终于还是走错了。啊，这个棋应该和了。哦，走错了。刚应该推兵的，现在就真的是和了。除非他做什么傻事。啊，这棋真和了，时间剩不多。哎呀，长江吧，没得玩。还是他要给我吃？贪心一下，看他要不要给我吃这个兵。啊，和棋。哎，好了，然后和棋已经算不错了，原本要死了。哇，发生什么事？我看一下。其实最后应该是要赢了，在最后应该是有赢的机会。那边因为时间的压力之下，不小心把一支兵给送了。就是在这个位置，这边应该推个兵就好了，这边直接推个兵。然后这边没看到他要抓着我这个兵，我直接走了一个车，啊，应该直接把这个兵推起。那这个可以靠的这个 F 兵赢的机会其实是很高的。那哪里走错？也许我不应该贪吃那支兵，我应该贯彻开局的原则。可能我这边应该多出一个子，这边多出一个子差很多。反正这个象跑不掉，这个象应该是跑不掉的。我这边应该简单多出一个象。对，没有必要那么着急去走这个后一期，因为这个兵要吃掉它，说难不难，说简单也不简单。因为如果让他走到1-4，我再想要吃它，它可能就有马 C3了。不过我认为我这边应该是没有下手的。可能我这边应该直接走马吃1-4啊。因为我马吃的话，它不能后吃，如果后吃的话，这个车一出来其实是真的。对，我觉得应该直接用马吃，因为我用这个兵吃有一个缺点，就是虽然它这边这个是一个弱点，然后但我这个低兵也不那这个低兵兵的这个兵毕竟是压的比较低一些。那我最后虽然吃到这个兵，但是我这个第6成为一个比较致命的问题。
Hello everyone. In this video we're going to be simplifying a logarithmic expression. We have a to the power ln a divided by ln a, and we're going to simplify this expression. I'll be presenting 4 methods, and we'll start with the second one this time. So my second method basically involves substitution, and a lot of these methods are pretty much substitution. So I'm going to call ln A something. How about ln A equals x? Okay. Now, since ln means log with base e, by using the definition of logarithms, I can write this as a equals e to the power x. Again, I use the definition here. And now, if we ln both sides, we get ln of ln A equals ln x. Great. So let's go ahead and substitute these into our expression. We have a to the power ln A over ln A. And notice that ln A is equal to ln x. So we can write this as a to the power ln x over x. And now notice that a can be written as e to the power x, so let's go ahead and substitute that. So this gives us e to the power x to the power ln x over x. Now one thing that will be helpful here is bring the ln x inside as an exponent and leave the x outside, but x is going to be multiplied by 1 over x, so they're going to cancel out. And we end up with e to the power ln x, which is x. Awesome. So even though we got an answer in terms of x, we can always turn it into something in terms of a, because we know that x equals ln a. So our original expression then, a to the power ln a over ln a just becomes x, which is ln a. Great. This will be the end of first method. Let's go ahead and, second method, sorry, because I started with the second method. Now let's go ahead and take a look at the first method. My first method again uses substitution, but it's a little different. Instead of calling ln A x, I'm going to call the whole thing something. So I'm going to set ln A over ln A equal to b. Okay, to b or not to b. From here, we're going to get, if you cross multiply, you're going to get ln A equals b times ln A. Now, b can be moved and it can be made an exponent, so it's going to become ln A equals ln A to the power b. Sweet. Now, we have ln's on both sides. We can kind of un-ln both sides, or we can do e to the power both sides, right? And that's going to give us the following. E to the power ln A equals e to the power ln A to the power b. And e to the power ln something is always going to be that thing. So from here, we're basically going to get ln A equals a to the power b. Awesome. Now what does this give us, right? Well, ln A equals a to the power b, but what is our expression? Well, if you look at our expression carefully, we have a to the power ln A over ln A, and we call this b, therefore our expression is actually a to the power b, which is ln A. So that's going to be the answer. Just like with the second method, first method gave us the same answer, and of course it should, right? All right, let's go ahead and take a look at the third method. Now my third method is going to use the formula for change of base. And remember, we used this formula recently for a logarithmic equation, I think. So change of base works like this, and it works with any base. So suppose I have log n with base m. I can just write this in a different base, like let's say use x base x. So we can put the bases first, and then n is going to go here, it's going to be upstairs, and m is going to be downstairs. And obviously we can use any base, so I can also use ln. This is going to be ln n over ln m. Great. So now, how are we going to use the change of base here? We're going to use it backwards. So we have ln A over ln A. Now look at this expression and look at this expression. Aren't they the same? Pretty much. If ln A is equal to n, then A is equal to m, so on and so forth. So by using the change of base backwards, we can write this as, so let's go ahead and call this C, for example. It's going to be like ln C over ln A. And now I'm going to write this with base A. So this can be written as log C with base A. Notice that this is going to go here and this number is going to go here. Awesome. Now what is the good thing about being able to write this with a base A is, remember, our original expression has base A, right? So the base is A here, that's why it's important to get a log with base A. Alright, great. So now let's go ahead and substitute that. So we have A to the power ln A over ln A. Now I'm going to replace ln A over ln A with log C with base A. So it's going to be A to the power log C with base A. So it's going to be like this. Okay, great. And from properties of logarithms, and I think we can prove this very easily by using, setting this equal to something and then logging both sides, this is going to equal C. So when these bases are the same, you basically get this expression right here, whatever that is. Okay, great. So they are, in other words, they cancel out. Okay, so this is equal to say C, but what is C, right? We kind of have to go back and see what C is, and C is equal to ln A. Remember, we can back substitute from there. So C is equal to ln A, so our expression is equal to ln A as before. So now let's go ahead and take a look at the fourth method. All right, great. So now the fourth method, all right, so the fourth method is the following. So I have 8. All right, so the fourth. Alright, so the fourth method is the following. So I have A to the power ln A. By the way, this problem is from a math Olympiad in Russia. I can't remember the book that I've seen it in, but I know it's an Olympiad problem. Or a math competition, whatever you want to call that. So now I'm going to focus on 1 over ln A, because 1 over log something can be converted to something else. So I'm going to write it like this. A to the power 1 over ln A, so I'm going to get that inside, and then everything else will be on the outside. And now I'm going to simplify what's inside the parentheses. So to simplify this, I'm going to use a basic property of logs. So if you have a log, xy and log yx, as long as they're defined, right? This is always 1. They're reciprocals. And you can easily prove this by using a change of base, because one of them is going to be ln y over ln x, the other one is going to be ln x over ln y. And this is why, as long as these are not 0, and obviously they can't be, right? They shouldn't be. Okay, great. So now from here we get this interesting identity that if you have 1 over log something, then it just switches the numbers around. So x and y kind of switch around, which means we can use that property here, because ln is a log, so we have now A to the power 1 over ln A, and then that is going to be raised to the power ln A. Now, this can be written as A to the power 1 over log A with base E, and now that's going to give us, when you switch the E and the A around, this is going to be A to the power log E with base A, and then that's going to be raised to a power. And then now, notice that this is the same thing as E, so we get E to the power ln A, and as you know, it's equal to ln A. And this concludes the fourth method, and this brings us to the end of this video. There's a fifth method, which uses something else maybe, but I'm not going to talk about it. Anyways, this brings us to the end of this video one more time. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.
3重起司龙卷风饼皮，必胜客1元好运龙虾干贝披萨，快出好运元！
Hello everyone. In this video we're going to be solving a radical equation in radical ways. I'll be presenting 3 methods, and let's start with the first one. So obviously my first method is going to be a little bit more painful than the others. So let's go ahead and evaluate this expression in the general sense. So I'm gonna try to evaluate what this looks like in terms of x. So I'm gonna go ahead and call that y, and for convenience sake, I want this y to be positive as well as x to be positive. Great. Let's go ahead and square both sides here. That's going to give us x plus the square root of x plus the square root of x plus so on and so forth is going to equal y squared. And then notice that part of this expression is the same thing as y, this part, so that we can set it equal to y. And this gives us an interesting equation in two variables. X plus y equals y squared. Since our goal is to evaluate this expression right here, we're going to be solving for y. Alright, let's go ahead and do it. Let's put everything on the same side. We want to make it quadratic. Y squared minus y minus x is equal to 0. Now to solve this quadratic, let's go ahead and use the quadratic formula. If we do, we're going to add y equals negative b plus minus the square root of b squared, which is 1, minus 4ac, which is 4x, and then divided by 2. Now we end up with two solutions here, obviously, but one thing to keep in mind is square root of 1 plus 4x, since x is positive, this is going to be greater than 1. So if you subtract 1 minus this expression, then we're going to get a negative value. In other words, we want the y value to be positive, therefore we're going to go with the plus sign. So this is going to be my y value. Great. So now we know that y is equal to that, so we do have our expression. Let's go ahead and take a look at our expression one more time. So we have x plus the square root of x plus the square root of x plus dot 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 is equal to 16, right? Okay, great. So now we know that this part is equal to this radical expression right here, so we can write it as x plus the quantity 1 plus the square root of 1 plus 4x all over 2 is equal to 16. And then from here, we can make a common denominator or multiply both sides by 2. That's going to give us 2x plus 1 plus the square root of 1 plus 4x is equal to 32. And then let's go ahead and isolate the radical and put everything else on the right hand side. That's going to give us 31 minus 2x. And then we're going to square both sides. When we do, let's go ahead and do it. When we square both sides, we're going to get the following. 1 plus 4x equals 961, which is 31 squared, by the way, minus 2 times 31 times 2, that should be 124x plus 4x squared. I know some of you guys are thinking, well, why is he complicating these things? I just want to show you different alternatives. You may or may not like it, but I just wanted to introduce these methods to you. All right, 4x squared, and now let's put everything on the same side. It's going to give us 4x squared minus 128x plus 960 equals 0. Everything is divisible by 4. Let's go ahead and divide. We're going to get x squared minus 32x plus 240 is equal to 0. Now our goal is to find two numbers whose product is 240 and whose sum is negative 32. And those numbers are easily found. They are 12 and 20. So we can write this as x minus 12 times x minus 20 equals 0. Yay, success. And from here we get two solutions. And I'm going to talk about why we get two solutions. Obviously one of them is not going to work because we're looking for a certain numerical value. So x equals 12 and x equals 20. Now, if you go back and substitute, for example, 12 here into this equation right here, you're going to notice that 4 times 12 is 48. Square root of 49 is 7. 7 plus 1 is 8. 8 divided by 2 equals 4. 12 plus 4 equals 16. So x equals 12 works, but unfortunately 20 doesn't, because 20 times 4 is 80. 81. You get 9. 1 plus 9 is 10. 10 divided by 2 is 5. 5 plus 20 is 25. Unfortunately, x equals 20 does not satisfy the radical equation. Therefore, we have to reject that solution. All right, great. Let's go ahead and talk about the second method now. My second method obviously is going to be shorter, right? No pain, no gain. So we're going to let me rewrite my original equation or problem. Now here's what I'd like to do. I'm going to subtract x from both sides. you know, something like this, right? Okay, I don't have to write the whole thing. 16 minus x, and then I would like to square both sides. Let's go ahead and do that now. If you square both sides, you're going to get rid of the, you know, the outside, the outer radical. You're going to get this, and the right hand side is going to be something squared. Don't expand it because this is going to be real cool. Now notice that our original expression is actually equivalent to this, which is 16. Yay, great. So we don't really have to work it out completely. We can just set this quadratic to 16, and as you know, there are two solutions. 16 minus x can be 4, which means x can be 12, or 16 minus x can be negative 4. This is what we mean by the negative square root. Normally, if you're taking the square root of 16 in the real world, it would be positive 4 only. There aren't two square roots in the real world. And this would be x equals 20, but as you know from earlier, x equals 20 does not work. Therefore, we end up with x equals 12. Awesome. Great, let's go ahead and take a look at the third method, and we'll just finish up with that one. So, let's see. Our third method is basically starting with the original equation again. Oh, I always want to write it first. Okay, great. And I'm pretty sure you found another way to do this. But anyways, so notice that I don't have a radical on the outside, but I can basically square root both sides, right? Let's go ahead and square root both sides. Let's see, this one probably. Square root, that's not a verb by the way, but anyways, who cares, right? Square root both sides, or take the square root if you want. So you're gonna get the square root of this, plus that, plus this, blah, 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 you know, so on and so forth. And obviously when you take the square root of 16, you're gonna end up with 4. Okay, how does this help us, right? Well, here's the thing. We know that this part appears in our expression, so we know that it's equal to 4 now. Great. So now we end up with a real simple equation, like it's linear, come on. X plus 4 equals 16, and this gives us x equals 12. In this case, since we're not squaring both sides, we don't really end up with any quadratic. So there are no extraneous solutions. Now, this brings us to the end of the third method, but not to the end of the video yet, because I want to talk about... This brings us to the end. End of the third method, but not to the end of the video yet, because I want to talk about something real quick. I hope you don't mind. In the general sense, if you have the square root of x plus the square root of x, oops, messed up on the writing, square root of x, blah blah blah. So these kinds of expressions, of course, we need certain conditions for x, but anyways, let's just say x is positive. So we can evaluate this. There are some good shortcuts. If the x value, if x can be written as the product of two consecutive integers, they don't have to be integers by the way, but anyways, let's just say x can be written as n times n plus 1, like 3 times 4, 4 times 5, 7 times 8, you know, so on and so forth, even though they can be radicals too, but anyways, if that's the case, then this is just going to be, when you have a plus sign, it's going to be the greater one, so it's going to be n plus 1. What happens if you have a minus sign? Then yes, you guessed it right if you said the answer is going to be n. of course, we're talking about the same factors here. Not the same x's, but the same, well, actually, sort of like the same x's in this case anyways. Well, this brings us to the end of this video. Thank you for watching. Hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. Share with us if you have any other solutions or alternatives. I'll see you tomorrow with another video. That's just gonna be. Hello everyone. Before we get started, I'd like to give a shout out to two of my newest members, Arnaldo Strasberg and Malik Haj Kadur. I hope I did not mispronounce your name. Thank you for becoming a member and supporting the channel. Members are given shout outs in my videos. You can easily become a member by clicking the join button. Alright, let's get started. In this video, we're going to be solving a logarithmic equation. We have log of x plus 2 with base x equals 2, and we're going to be looking for x values. So, I'm going to be presenting two methods, sort of, and we're going to be doing a little bit of calculus here. So let's go ahead and take a look at the first method first. I think at some point we gotta start with the second method to be more fair, like mentioned in the comments. Anyways, so I'm gonna differentiate this function, but I don't really want to deal with the derivative of the log function, which is in base x, by the way, something that we don't know. So I'm gonna turn it into something I know, natural logarithm. I'm gonna use ln. So we're gonna use change of base formula.
My job is to make college easier because students have a lot on them.
So we're going to write this as ln x plus 2 divided by ln x. Great. So this is called the change of base formula, and change of base formula can easily be proven using the definition of logarithms. So definition of logarithms is very important. So suppose our function f of x is ln of x plus 2 divided by ln x. Now I'm going to differentiate this function by using the quotient rule, and I'm going to differentiate ln x plus 2, which is 1 over x plus 2, multiplied by ln x, minus the derivative of ln x, which is 1 over x, multiplied by ln of x plus 2. And this will be divided by ln x quantity squared. Let's go ahead and make a common denominator and rearrange these terms. We can write the f prime as x ln x minus x plus 2 times ln x plus 2 all over x plus 2 and ln x quantity squared. Okay, we put it all together. Now my goal is to find where this function is increasing, where it's increasing, if it has a maximum or a minimum, so on and so forth. But in order to understand what's going on here, we kind of need to compare, or we need to look at the x ln x function. So suppose we have another function y or g of x, whatever you want to call that. Let's say g of x equals x ln x. Now, I'm not going to get into the details, but I just want to tell you that this function is actually increasing for x values that are greater than 1. All right, great. So, for our purposes, and you're going to notice that later on, the derivative is going to be negative. Okay, great. Why? Because x plus 2 is always going to be greater than x, and this function is going to be increasing. Therefore, this x plus 2 times ln x plus 2 is going to be greater than x ln x, which is going to make the derivative negative. Obviously, at the bottom, for x values that are greater than 0 is always going to be positive. Okay, great. Of course, we have to exclude x equals 1 all the time because it's going to make the denominator 0. That's why we kind of had to, did we not talk about it? Okay, we should have talked about it. X must be positive and x should be different from 1 because that's going to violate the definition of the log. We're not going to have 1 as a base. Great. And obviously x plus 2 needs to be positive, but x is greater than 0 already satisfies that. So our function is increasing, therefore f prime is negative, which means f of x is always decreasing. And I'm going to show you what the graph looks like at the end. So you're going to get to see how it behaves, so on and so forth. Okay, now, what is that supposed to mean now? F of x is always decreasing. We have a function that's always decreasing, and it is intersected by a horizontal line, which is y equals 2 in this case. So therefore, there will be only one intersection point. So how do you find that point, right? Okay, that's probably one of the biggest questions, and I know some folks don't like it when I say, hey, we're gonna just use guess and check, right? Okay, that's not what I'm gonna do. So here's what I'm gonna do. I'm going to use the change of base formula here, so I'm gonna write it as ln x plus 2 divided by ln x equals 2, and I'm gonna cross multiply. Ln x plus 2 equals 2 ln x, which can be written as ln x squared. Let's remember that x is positive and different from 1. Under those conditions, this is an identity. And from here now we can compare the insides, and this is going to give us x squared equals x plus 2, which is a quadratic equation. And then it can be written as x squared minus x minus 2 equals 0. And that can be factored as x minus 2 times x plus 1 equals 0. Obviously, this quadratic equation has 2 roots. It's factorable. It's all good, nice and clean. So from here we get x equals 2 or x equals -1. But let's remember our conditions. We said that x must be positive in order for our original function to be defined, right? Well defined, we do need that x is positive and different from 1. So under those conditions, we have to reject x equals -1 because it is not positive. Great, so we're going to go ahead and reject that, and we're just going to go with x equals 2, and basically that's going to be the only solution. Well, didn't we say that it's only going to have a single intersection point? But the algebra didn't give us that. It didn't confirm, but the graph will show you how it's confirmed. All right, great. So let's go ahead and kind of take a look at the second method. You can't really entirely call this a second method because we're solving a very basic equation. We arrive at the same thing, but a little different. Okay, so my second approach would be to use the definition of logarithms directly. Use definition of logs. Okay. What's the definition of logs? If you have log a with base b equals c, then this basically implies that b to the power c equals a. And of course, they both imply each other, so kind of like a two-way implication. So since we have log x plus 2 and base is x, and this is equal to 2, from here we can safely say that x to the second power equals x plus 2, and then we basically arrive at the same equation, x squared minus x minus 2 is equal to 0. And as you know, from here we get two solutions, x equals 2 and x equals -1. And you can kind of test -1 out, like plug it in here and here. You're going to notice that -1 cannot be the base, and you're going to have something that doesn't work. Obviously, we're talking about the real world. So x equals -1, like before, is not going to satisfy. Okay, great. So x equals 2 is going to be the only solution again. Now let's go ahead and take a look at the graph real quick and see how this function behaves. All right, great. So here's our function, and I kind of converted it. If you didn't, you could still graph it with Desmos, but I just wanted to show you the version that I used. And notice that our function, kind of like the purple one or magenta, whatever that's called, that color, it's a decreasing function. And what do you notice? That it's intersecting the horizontal line, which is y equals 2, at x equals 2. So 2 comma 2 is an intersection point, but it's also interesting that we have a vertical asymptote at x equals 1. Remember, that is the x value that makes the denominator 0, obviously, right? If you look at it this way. But when you write it as a log, you don't see a denominator, so it's a different story then. But anyways, those functions are equivalent, and we do see the single intersection point. Now this function kind of behaves interestingly because you kind of look at the limit as x approaches infinity. You can evaluate the limit as x approaches 1 from the right and 1 from the left. Notice that one is a positive infinity, the other one is a negative infinity, so on and so forth. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye. Hello everyone. In this video we're going to be solving a polynomial equation. This is a very special polynomial. You're gonna know why in a little bit. I'm going to be presenting two methods. And almost as always, let's start with the first one. Now, my first method is using factoring by grouping. So I want you to notice that x cubed plus 1 can be factored. X cubed plus 1 is called sum of two cubes, and sum of two cubes can be factored. This can be factored into x plus 1 multiplied by x squared minus x plus 1. If you want to know what sum of two cubes is, a cubed plus b cubed can be written as a plus b multiplied by a squared minus ab plus b squared. That's the formula I used here. Now, why did I mention that? Because if you look at the equation very carefully, you're going to notice that you can break it down to make it factorable. So my polynomial is x cubed plus x squared minus x plus 2, but it can be written as
polynomial
as the sum of two polynomials that have a common factor. What is it? It is x cubed plus 1 and x squared minus x plus 1. So what I did was I broke down the 2 into two pieces, and that gave me two polynomials or two pieces with a common factor. Great. So now I have the x cubed plus 1, which can be written as x plus 1 multiplied by x squared minus x plus 1. Again, it is from sum of two cubes. We just talked about it. And x squared minus x plus 1 is a prime polynomial, which means you can't really factor it, but you can always write it as 1 times itself. Great. So now I do have a common factor because x squared minus x plus 1 is a common factor. Therefore, we can factor this by grouping. So I can take out x squared minus x plus 1, and then I will take the x plus 1, and that's just going to give me x plus 2. Awesome. Okay, great. So that gave me two factors, one linear, one what is it called? Quadratic. I just forgot the name of it. And by setting this equal to 0, we can find the solutions very easily. X plus 2 equals 0 means x is equal to -2. That's one of the solutions, and that is the only real solution because the other solutions are going to be complex. You probably recognize this number here. If you use the quadratic formula, so set this equal to 0, solve by using the quadratic formula, you're going to get -b plus minus the square root of -3 divided by 2, which can be written as 1 plus minus the square root of 3 times I divided by 2. I is the number whose square equals -1. All right, great. So these numbers are special because if you think about x squared minus x plus 1, when it's multiplied by x plus 1, then it becomes x cubed plus 1. So by setting it equal to 0, you're basically finding the cube roots of -1 because this equation is equivalent to x cubed equals -1. Obviously, we have to add the condition that x does not equal -1 because we don't have that. We only have the quadratic. So that means we are looking at the complex cube roots of -1. And we are excluding -1 itself, of course. And those numbers can also be written in polar form. So x can also be written as cosine pi over 3 plus I sine pi over 3 for my radian friends. And then the other solution is just going to be cosine of 5 pi over 3 plus I sine 5 pi over. If you look at the unit circle, you're going to know what I'm talking about. But you could also write this as x equals cosine of pi over 3 plus minus, if you don't want to deal with a large angle, just want to keep it small, you can also do it that way. All right, great. So now this is the first method. Let's go ahead and talk about the second method. All right. The second method is obviously a different idea, and I'd like to introduce that to you as well. X cubed plus x squared, and I'm hoping that someone will find the third method, maybe Cardano's formula or something else like that. Okay, so my second method uses the rational root theorem. What is that? Now, rational root theorem says if there are rational roots, and of course there may not be, in this case we do know there is, but suppose pretend that you didn't know the answer. So rational root theorem tells us that if we have rational roots, then since this is a monic polynomial, meaning that the coefficient of x cubed is 1,
空虛的我，對否等你就似這歌？你知不知道？你知不知道？我等到花也謝了。你知不知道？你知不知道？我等到花也谢了。等你等到我心痛，等你等到没有梦，所有感觉已成空，就让一切都随风。你知不知道？你知不知道？我等到花也谢了。你知不知道？你知不知道？我等到花也谢了，我等到花也谢了。
Divisors of 2. We only have like 4 possibilities, plus minus 1, plus minus 2. So we're going to look at those candidates. So let p of x equal x cubed plus x squared minus x plus 2. Then p of 1 is equal
来饮一首老诗，喝一杯老酒，明月啊，别笑我痴，别笑我狂。窗前明月光，疑是地上霜。举头望明月，低头思故乡。
shall be the wiser.
是你吧，
Job's done.
总是在寂寞夜流亡，你是人是却是离忘，仿佛告诉我生命本无常。来一首老诗和一杯老酒，明月让我拥抱，带我翱翔。窗前明月光，疑是地上霜。举头望明月，低头思故乡。窗前明月光，
My brothers.
Job's done.
举头望明月，低头思故乡。
Out with it.
Upgrade complete.
Enlighten me. prepared.
Research complete. Upgrade complete. Upgrade complete.
Enlighten me.
Upgrade complete.
Bravo, mesdemoiselles. Camille Thomas, nommée cette année dans la catégorie Révélation soliste instrumentale. Et Béatrice Berru au piano. Bravo et merci.
Enlighten me. Out with it.
At your call.
I am prepared.
Research complete.
不知不覺已變淡，心裏愛。原諒我這一生不羈放縱愛自由，也會怕有一天會跌倒。
More lumber is required, sir. More lumber is required.
I am prepared.
Upgrade complete.
What would you ask of me?
Upgrade complete. Upgrade complete.
寒夜裏看雪飄過，為着冷卻了的心窩飄遠方。風雨裏追趕，我會分不清影蹤。天空海闊，你與我可會變？
Upgrade complete.
原諒我這一生不羈放縱愛自由，又會怕有一天會跌倒。背棄了理想，誰人都可以。怕有一天
That's it. Out. My brothers. That's it. My brothers. I bid you. Out with it.
At your call. Upgrade complete.
Out with it.
Upgrade complete.
I am prepared.
Research complete.
My bidding.
带你品味乡村音乐的专属向导，订阅 YouTube Music Premium 免费试用1个月。
你知不知道？你知不知道？我等桃花儿也谢了。
Research complete.
Out with it.
旁人來靜靜看我到底愛上但什麼？旁人來會關心中安慰愛已沒結果。熱烈地開解一生，等你也是奈何，彷彿我在拼命要起可援助。旁人來靜靜探聽我昨天哪裏出錯，何時從逢迷失中飄起這首歌？是舊若是真執着的某個故事，可惜這份信念到今天多麼無錯。天天親親的你，我打算每日離舊。孤孤單單的我，最想跟你似這歌。飄飄忽忽的我，我真的決定離開。喺空空虛虛的我，會否跟你就似這歌？你知不知道？你知不知道？我等的花儿也谢了。你知不知道？你知不知道？我等到花儿也谢了。
Out with it. My bidding.
More lumber is required. Build more farms. Build more farms. Build more farms. Upgrade complete.
對否等你就似這歌？你知不知道？你知不知道？我 越显流。你知不知道？你知不知道？我等到花儿越显流。你知不知道？你知不知道？我等到花儿越显流。你知不知道？你知不知道？我等到花儿越显流。我等到花儿
Research complete. Out with it. No one shall be wiser. I bid you. I am prepared. Enlighten me. What would you ask? Out with it. At your call. Defending your name. Defending your name. Enlighten me. What would you ask? Justice will be served. Defending your name. Justice will be served. Defending your name. Justice will be served. My bidding. At your call. Enlighten. More lumber is required. More lumber is required. More lumber is required.
是缘是却是迷惘，仿佛告诉我生命本无常。
来吟一首老诗，喝一杯老酒，明月啊，
别笑我痴，别笑我狂。
窗前明月光，疑是地上霜。举头望明。
各位西洋棋朋友们，大家好，这里是皇家西洋棋学院，我是瑞老师。那今天新年嘛，我们再录一个特别的影片。那今天我拔掉这个皇后陪大家下棋，那输赢不重要啊，那主要是陪大家这个欢乐一下。好，那我们就开始准备我们的第一盘对局。好，那我们就第一盘棋开始啊。开始啊，局。好，那我们就第一盘棋开始啊。那这个对到的人，好，那我这边让后习惯是下这种古印度的阵型啊，因为比较简单。然后再来是可以避免子力兑换。那没有后的情况下要小心避免换子，因为换太多子的话，基本上就完蛋了。 好，那少一个后的情况一样是要正常的出子，要出子的事情没有变。那当然正常情况是肯定是会输，可是，哎，总之试一试，好玩。毕竟有时间限制。那再来这个对初学者来说也是一个很好的训练啊，在多一个后的情况下，在时间压力的情况下，要能准确的把一盘棋赢下来，也不是很容易的。这边可能要交换黑格象封起来，能封起来尽量封起来。我操！我刚以为他在吃过路兵，哎，反而跳进去了。这个马还是挺可以的，这个马在中线还不错。很像走出了什么？啊，橡皮筋陷阱。无双，是盛世，问题不是很大。这边可以吃，不行，他可以马吃，避免换子。下一步过来。拉一下吧。这捉双了，兔线应该是没了这线。啊，这是没了。他下的还是很不错啊。这不行，投降。哦，看他要不要再来玩一局。哎，等一下，这样再下一局很像是变成我是黑色是吗？好，我再发一个新的吧。好，那第一局恭喜我的对手成功了。好，那我们第二盘棋继续使用刚刚的古印度防御的阵型。好，不知道是不是同一个人，看起来有点像，因为他摆的阵型跟刚刚的那一盘棋的有点相似。不过刚刚那个人的马不是跳在这个位置，可能一样，可能不一样，我不确定。哎，感觉风格不太一样，这个下的比较凶猛一些。 确实多一个后啊，这样的下法是比较聪明的。趁多子优势的情况下发起进攻。然后再来是理论上他透过换子就可以简单赢棋了。啊，但我们总之尝试嘛，我们得避免去换子。那他有可能透过弃子的手段，这边是抓了我这个车先，我车先跑一下，他现在要杀这个点了。他有可能带推，那我马可能过来挡住一下这个后，先偷一下这个车。这个马一定是要这里，但是下一步他有可能这样炸掉这一匹马，炸掉这个马就凉凉了。啊，确实，象过来是最好的一步棋。这怎么办？待会他吃掉这个马，我兵一吃，后再一吃，这个点，这点一炸就没了。先开这个一线吧。这个马还没跟，不过我这边咬这个马。啊，尽可能把局面复杂化吧，这个局面简单的话必死。下一步他把这个象一拔，我就要没了。这个点一旦被杀穿，吃这个试试看。啊，非常有威力，这样子直接下来要死了，基本上。我还可以往这个钻，他选择先吃马。吃多一个子。哇，这个不能吃了，这个吃就没了。先抓一后，下一步再吃象。那他还可以吃这个。应该是吃兵吧，后吃兵，再抓这个车。哎，他没吃。他没吃，我吃象。将一个，然后抓一个，调一下我象的位置。这后得走，然后下一步过来。他要吃这个兵，这个兵不能给他。有没有可能把这后抓死啊？不可能，那后还有这个格。而且我象不能随便去堵住这个点，因为他可以简单走这个，走一个这个，守一下这个兵，牵一个。他不能乱牵，可以牵吗？牵一下。下一步要炸这个马，将这个躲开。哎，有机会，局面有点乱，嘿嘿嘿。哎，这个后，这我怎么吃比较对？直接吃。然后就这个，小心下，这个棋1、2、3、4，1、2、3、4、5，我只少一个边，理论上不会输。哦，我在干嘛？吐血了。 还行还行。兵给他。这象得留着。等一下，张起了，拍死对手。哦，顺利拍死对手，理论上要输了，对不起。啊，不过有时间压力嘛。好，那我们准备进行第3盘对局。好，那么我们第3盘对局开始，那我们应该是继续采用这个。哇，这个1925分，然后8个后，哇，这个是然后虐杀我了，这个王都直接飘出来了，这不容易啊。不过确实啊，这个多一个后了，高兴怎么下都行，然后正常下都是延期。这王用一个骚操作进行了手动换位。怎么办呢？他没有走得很积极，那我们这边也跟着走得消极一些，因为这种积极发起进攻的权利啊，是在多子的人手上，像我们这种少子的一方，只能消极等待，消极等待，主动进攻肯定要出事啊！那这边送兵了，这边再送一个兵，亮亮。过来，右拐一下，然后吃这个马，钻进去，这兵应该是没了，他一支兵都不给我，下一步象过来。记一下这后，哎，这样就被迫就换一个子。如果他吃的话，我可以象吃。后过来，怎么办？加一下，兵下来的话，我马过来。被换一个，还是他不愿意换？玩起来，前面收一下，抓马跑一下。位置其实还行，应该一时半刻将不死我，对不起。这个马要被换掉了。 抢走这个马过来，但是他兵吃我吃，然后他兵一下来，待会就要杀旗了。消极等待一下，希望他自己推下来。上了，硬着头皮上。哎，这样的话我把后吃掉了，那这个棋还行，可以挣扎一下。这个兵动不了。希望他推下来。这样是，这样就是见人打交换了，这不是我乐意见到的。哎，怎么无仇一犯？哇，这一支兵有点问题。哎，他给我时间，嘿嘿嘿，他不想靠时间拍死我。好，不过这个棋确实怎么样，我都要没了。好，恭喜这个对手，我们这个棋迷朋友，在这盘对局取得了胜利。好，那我们进行下一盘对局。好，那第4盘对局开始，那我们依旧才坚实的这路阵型。主要是这个棋可以比较容易避免对方子力，因为他是把后还给我。想要正正当当的跟我下盘棋，哎，这一步好像走错了，应该走另外一步才对。走的有点奇怪，不过没关系，冲吃。这边抓了我狙一下。抓一手，对，调一下，偷袭一下这只。狙带出来，拍一下这个。哎，他刚捉双我狙吗？ 偷这个兵，不行，偷不到。这里。消极等待，扫子就是消极等待。啊，一开始没扫，就是他把后还给我，他去换了这个 A 兵。现在我是落后3分。大概在想怎么去调整这个棋。这个棋如果去换这个象。这个格子是个铁格，看一下，然后分往这个格子，这里会受伤，他这样不让我。调一下。盖一下，哦，这边有一个战术。这边捉双了，有吐血。哎呀，这棋没了。啊，这棋没了，肯定是没了。犯太多错误了，嘿嘿，他给我时间加回来，啊，但是多少时间都不够。嘿，好了，这棋别投了。好，我们进行下一盘对决。我发现3分钟边下边讲还是比较吃力，不过没关系了。好，那我们开始第5盘对局。这边有这个好一点，限制一下这个格子。